Thank you very much, guys, for attending this little meeting that we are doing. We have a special guest today, which is Ariel. Ariel, welcome to our team. Thank you for sharing your knowledge with us. And guys, along with our IE COP, we wanted to bring you people from outside of the company that share some knowledge, some interesting topics with us. So thank you very much again. And Ariel, all yours.
Thank you. Thank you for the introduction. Thank you for the kind introduction. Let me see if I can share my screen. Yeah, share my screen. Okay, I found it. Please let me know if everyone can see my screen, please.
Yes, we can see it.
Sure,
Yes.
I can see.
Okay, let me just put this over here. Okay. First of all, thank you for the invitation. It's a really pleasure for me to share the little knowledge that I have. Like I always said, I can give all the knowledge that I have just for the half that I don't know. Why? Because every time that I read something, I learn something new, I realize there is a lot of information, there is a lot of knowledge in the world that we don't know. So that's why I really like to share what I know with everyone. So feel free to ask me any questions after the presentation, because I have a short time to present the whole process, and it's a really huge process. So please. I basically one engineer. So let's go ahead. So first of all, my name is Pedro Gomez, currently the general manager of EvoPoint, and I also work for Microsoft as a solution architect and DevOps architect for West of Europe. Currently living in Oud-Horen, north of Holland, since 2 years with my family. Yeah, I have a little experience with Azure since 10 years. I work with Azure since the first release. Yeah. I also I feel really passionate with DevOps and also the new practices. So I'm going to share a couple tips and knowledge regarding this. Okay. So the agenda, we are going to cover basic concerns. I make a typo mistake here. The GitOps, what it is, GitOps tools, the GitOps pipeline, the conclusions, and also the end of the presentation. So let's start with the basic concerns related with what we're going to talking about, because GitOps is the evolution or another flavor of the DevOps framework, but depends only via declarative way or the declarative model. So let's start. What is Git? Git, I think we all of us know it, is a technology that helps us to control our source code in a branch way. This allows us to use the ramification. Yeah, there is a couple flows that we can use, like Git flow, GitHub flow, and another ones. Then another technical practice that we should know is continuous integration. Why? Because to accomplish a declarative way, you should have a really strong continuous integration process on your organization. So after that, we should also know about continuous delivery. The difference between continuous delivery and continuous deployment is continuous delivery requires a manual approval or a manual intervention after the provisioning. The continuous delivery is basically automatically based on a specific metrics or let's call it this way, configuration, right? So GitOps is basically doing all of this together, but in a declarative way. When I say declarative way, is the entire definition of the deployment, the entire definition of your application, like the infrastructure, the communication, the image that you need to use, the ingress, everything should be declared in files. In this case, YAML files. So what I need to use GitOps as a strategy? First of all, you need an orchestrator like Kubernetes. Why? Because Kubernetes is basically the entire engine that you can use as declarative way for the automation of your workloads. There is basically your applications, right? So let's make a little step back. We're saying a lot declarative way, but there is another way that is the imperative way or the imperative model. What is the difference between one of them? First of all, the declarative model is basically the entire state of configuration that you should have. Is what I have in this file is the stuff that I need to have on my environment. This and nothing else. Imperative way is basically instructions that you can share to the environment to do a desired state of configuration, but it's not a desired state of configuration. Why? Because it depends on the instructions. If you change the instruction, you can have different results. So that is the difference between declarative way and imperative way. This means, this is the illustration that I really like. In an imperative way, you can have a control with two, let's call it these options, one for the volume and the other for the channel. So if you press the volume to up, it's going to increase to the no matter which a specific number. It's going to be an infinite possibility of volumes and channels. But in a declarative way, you have only the specific numbers that you declare. So you don't have any other options. It's this or nothing. So this is a good way to illustrate it between one and another one. So GitOps. We say that GitOps is basically the evolution between continuous integration, continuous deployment, and continuous delivery. Is the framework that allow us to handle our cloud native infrastructure based on code. Let's call it like this way. So what is GitOps? It's the way to implement continuous deployment and deliver it for cloud native applications. It's focused on development-centric experience. This is really important. Why? Because it's everything defined via repositories, via a specific configuration that should be inside in your GitHub, Azure DevOps repo, or any other platform that you use. Because Git is the only source of truth. So it's focused on development-centric experience. This is not for people that really wants to use portals to deploy or configure their applications. This is for real deal. Engineers that know what they are doing or what they have and deploy it in a specific environment. Let's call it like this way. So GitOps is a distillation of the best practices to manage or management the deployment for containerized application as well as the cluster infrastructure on to which they run. This is a really nice definition of GitOps. Why is the distillation of the best practices? Because you should know and also mastering some skills, like for example, versioning, continuous integration, infrastructure as a code, containerized with Docker or any kind of containerized application platform. You should know infrastructure. You should know the security. You should know techniques like desired state of configuration or any other configuration management technology, right? So GitOps is basically the last step of the continuous deployment process for cloud native applications, right? So let's recap. which are the principles in GitOps? First of all, the entire system has been described declarative way. So in which technology? Well, we have YAML, and YAML supposed to use, you can use customize, you can use Helm to basically do it dynamically, but in the base is YAML, right? Canonical disaster configuration state based on versioning in Git. Why? Because if you are changing your infrastructure, you should have some controls. So it's really necessary to have the repos and everything organized based on repo or applications, right? So it's pretty important. Know Git. You should know Git. Approved change can be deployed automatically to the system. This is one of the principles on GitOps, that I don't really need a pipeline to push my change to the cluster. Someone should do it, and not me, and not the pipeline, because there is an issue there. And 4, software agents ensure that correctness and the alert. In this case, basically you have the entire monitoring of your deployment or your change based on your infrastructure. So let's take a look. System is describing a declarative way. This is basically means that are your configurations, like for example, ingress control, egress control, the deployment definitions, the escalation, the lock configurations, everything should be in files, not directly, not connecting to the cluster via kubecli and apply some wonderful Helm repository that you find on the internet. No, don't do this, guys. This is not acceptable. Seconded, we should have everything in Git, because Git is the single source of truth and is the single place to operate the change, the new configuration, and also to modify or eliminate the configuration in all our environments. And we should have an operator. In this case, I really like this guy. There is ARGOCD. This little guy is going to help us a lot, because this tool lives inside Kubernetes, inside the controller. He's an operator inside our cluster and continues. This guy basically continues to check the current configuration of our deployment definitions and check if our repo have another change and automatically apply it. And if it's something wrong, he take back this change. You can configure it some webhook and did a git revert and go back to the previous version automatically. That's why ARGOCD for me is one of the best operators for GitOps. So, what is an operator? First of all, ARGOCD is the operator that we are going to talking about, or we're going to show today. ARGOCD is a declarative GitOps continuous delivery tool for Kubernetes. Like I said, declarative, not imperative, right? So, this project was created by Intune, the company that creates FreshBook, or no, QuickBook, right? Have a really nice user interface. You can solve the entire deployment definition in real time. If something fails, you can also see the logs, and also you can check if something is missing in your configuration. And also have a really cool integration with role-based authentication system and also single sign-on. For example, Azure Active Directory, Okta, OneLogin, any of these enterprise single sign-on. So, CI/CD pipelines and GitOps, because you cannot have GitOps without pipelines. So, we have two different base deployments. One is the traditional. I have my application repository, I have my build pipeline. This build pipeline creates my image, send this image to the container register or to my Docker Hub, and also I have another pipeline with the environment repository, like the manifestos. But I need something for deploy my change on the environment. So for that, we normally use agents pipelines, right? Actually, double pipeline that use the service connection to the Kubernetes environment, and we apply the manifesto directly on Kubernetes. That's the, let's call it this way, the puppy way of doing it. This is for kids, right? Because this has a lot of opportunity of improvements. You don't have control of what is happening. You also have to expose your Kubernetes cluster to the agents, the actual DevOps agents or your orchestrator agents, because don't have the integration to use the APIs directly. So this is like the traditional way of working on Kubernetes, the push-based deployment. But there is another way, the way that I'm going to show. There is the the pull-based deployment. That is, I have the same process from the generation of my image and also the desired state of configuration in my repo, but the difference that I have a guy, my little friend ARGOCD, is going to always take a look up to my container register and also to my repository with the definition of the deployments. And this guy is going to check the specific branch and also the last commit that I sent to them. If this guy detects that I have a different commit, it's going to show me, hey, dude, your repository is updated. You have two choices, to auto apply the change based on a frequency or apply it manually. Fair enough. And Argo is going to do the checkout for the repo and going to apply the existing change on the cluster. Why? Because this application works inside the context of Kubernetes as a system. Let's call it this way, in a specific namespace. So I can improve two things in this way. I can improve that my cluster should not needs to be exposed to internet, because I can create an ingress control specifically for my ARGOCD in a specific context or a specific APIs. And also, I don't have to deploy anything. ARGOCD is going to do it for me. And also, I can check in real time what's happening if something is wrong. So, what is the key benefits of doing this? The first of all, you improve the observability because you can solve everything in real time. And you can fix really quick what is happening. You improve the security because you don't have to expose the API for Kubernetes to the internet or any other networking context. You simplify the disaster recovery because it's just a git commit. If I want to do rollback, I can do the git rebirth or rebase, whatever, or I can just do the rollback to the previous version if I use a really strong semantic versioning on my Git flow or GitHub strategy. And also I increase the productivity because the automation of the deployment is basically in real time, and also I receive feedbacks in real time. So it's really cool. But let's talk about what is not the coolest stuff to do using this strategy, or the bad part. You need the structure of your environment in your repository. Basically, everything should be in place on the on code. Not just a part, not just like one small piece. Everything. If not, it's going to be a problem. Another thing is the secret manager, because secret manager is basically when you have a specific value and you encrypt this value as a secret using the certified manager or the secret manager or the vault of Kubernetes, but you should have the value in plain text at the beginning to encrypt or make the secure version inside Kubernetes. But if you have a declarative way, you can expose this information in one specific moment. So there is not a really easy way to work with secret certificate managers with ARGOCD at the moment. There is a couple workarounds that you can do. For example, you can create a environments variable in the middle of the deployment and use that for generate the certificate manifesto and apply it. But there is not a native solution. Okay, so before going to the demo, I'm going to show you to all of you guys how this pipeline looks in an enterprise level, because it's not just GitOps. There is a security controls that we should be in place to have the right adoption of this deployment pattern. Can you see my screen? Well, you see all the icons?
Yeah, it's
Yeah. I see it.
but we can see it better.
Okay, let me just try to go per stage, right? So at the bottom, we have like the continuous integration and continuous deployment process, right? So everything starts with my pipelines and my application. So I should first build my application with the right controls, for example, Sonar Cloud for analysis code, Snyk for vulnerabilities and security. And after that, I have to build my image based on my application build. So we need to have a pipeline to take the output for the build and generate the Docker image. And after the build of the image, we should also scan the image to see if the base image that we are using or the Docker file itself have some vulnerabilities or security issues. So for that, we should also have a tool like Betacode, like Snyk, like Fortify, whatever. And after that, after we make sure this image is compliant and can be pushed to production, we should push this to a container register or Docker Hub, right? So there is something that is happening in between all of this stage. Is the versioning. Every time that I build something, I make a specific version using the semantic versioning strategy, right? Because every time that I build an image should have a specific version of that specific change to make sure that I have a strict history of my change, because it's needed for the rollback, right? So after I push my image to the container register, I need to do something else. I have to notify to my desired state of configuration, my GitOps repository, that I have another version of application ready. So I should update my deployment definition and change the image tag or the image name. So for that, we should create a pipeline that automatically get triggered for the change of the Docker image and push this change to the GitOps repository. And from the GitOps repository, we basically automatically sync this with ARGOCD, and ARGOCD deploy the change on Kubernetes. Looks nice, right? Sounds like a dream. But it's possible, guys. With a lot of work and patience, you can do it. So,
what kind of magic is that?
Yeah, it's not just magic. It's magic. So let's take a look of how I can follow this step, what I should take in consideration, and how all these pipelines looks. So give me a minute. Sorry that I'm going fast because it's a lot of information. I try to cover everything in a high level, to be honest. So
it's good. Very good.
Fair enough. Okay, so I'm going to share my screen again. Can you see my screen, guys?
Yep.
Okay, fair enough. So, as I mentioned on my previous in the previous presentation, we should have a specific repo for the GitOps definition. So here, I have the definition of my Azure DevOps agent. As you saw here, guys, I have 2 agents available with a specific version. These 2 agents is basically the representation of my deployment file in this repo. Okay, so this is my ARGOCD. ARGOCD automatically check if my current deployment is on the same let's say status of my repo in my specific branch, that is master. So right now you can saw that I have the commit, this specific commit ID, and the current repository have another one. So I don't have the latest version. So I have 2 options. First of all, I can click on sync, and ARGOCD is going to do his magic, or I can configure the project to automatically apply the change, but I don't want to do this. So I'm going to show how, if I want to modify the quantity of agent, what I have to do as a, let's call it this way, like a DevOps administrator. So first of all, I'm going to make a branch from master. In this case, I'm going to create a feature, new agent capacity. Okay. So in this new branch, I'm going to do a little modification to my specific agents. So I'm going to change the image to use the latest version that I create. And also I'm going to change the replica to 3. Like I said, I have 2. My private pool agent, my private pool only have 2 agents available. So I'm going to deploy another agent on my current cluster for speed up the builds. Right? So I'm going to click on commit. Update the deployment YAML is going to be the commit, right? So after that, I'm going to create a pull request to master. Title, same thing. Let's use any task because it's based on the policy. Yep. So I'm going to approve and complete. Yeah, I'm going to override it. Why? POC. Don't do this in production, guys. Don't be like me. This is just for demo reasons. So, okay. So I'm going to delete my branch. I'm going to complete the work. No, I'm not going to complete. I'm going to override the policies because I'm doing a proof of concept. Here we go. Boom. Now, if I go back to master, if I check in commit, I have a new commit available. So if we wait for I think that 2 minutes, this commit is going to change for this one. Let's see. Let's wait. This one was 3 months ago. Normally this, the webhook check the repository every 3 or 5 minutes. Also depends of the configuration. Okay, now I saw that is 2 out of sync. This means that is getting the latest version in some point. No. Sync status. Yep. 3 months ago. And also you can also the sync status. If there is an issue, automatically it's going to throw you, hey, there is a specific issue in your application and blah, blah, blah. So let me enable auto sync. Oh, now it's working. You saw here that is try to sync my repo automatically from this specific version, but it's going to fail. Why? Because I know this specific deployment definition have an issue. That's what I don't want to deploy it. But in some point, he's going to also check again from the pipeline and is going to deploy it. So let's wait. Now it's syncing. Oh, now you can see it here. This is the new deployment. This is the update YAML. It's the same commit that I sent. This is the one. And also here we can saw the commit ID. So if we check the commit ID, is the same. Fair enough. Now it's deploying a new agent. As you saw here, I have another pod that is going to provision it. So you can see in real time what is changing in my infrastructure after my change. So I'm going to have another pod after a couple minutes because you see, now I have another pod available. If I refresh here, now I have 3. It's automatically. I deploy my entire definition without making one click. So let me do a rollback. I'm going to reduce the existing configuration to have only 4, like only 1. You saw all these agents is because normally I have a specific like tolerance of risk, like the availability of the pods for the service. So after a couple minutes, this is going to refresh. Now I have only the 3. This is for prevent the downtime or affect my users. So let's do a rollback. Let's do the same. I'm going to reduce my agents to 1. Now I have 3. I'm going to reduce to 1 because no one is using it right now. New branch. So it's like hot is a fit. Reduce agents. Onto my files. Using my branch. Hey, I just want 1. Meet. Same process. Here we go. Yep. Setting up complete. Complete. POC. I should modify the name. This is doesn't matter. Okay, so I send the change. Thank you, Microsoft. So it's nothing yet. I have to wait for a couple minutes. Meantime, let me check. I still have my 3 agents. Nothing is happening. So we should wait. So now, how I can connect my Docker pipeline to my repository? Well, for that, you should create a big pipeline to handle all the steps. For example, this is a pipeline that I create to build my image, push the image to the container register, and also to make the pull request automatically to my repository. So I have 4 jobs. First one is the Docker lint for check the good practice in my Docker image. The second one is the build agent. It's the build job that check the versioning, well, create the version like I saw here, and build the image and also push the image generated as an artifact The other job is to push this specific image to the container register, as we saw here. And for the last part is the GitOps push, because I should merge, I have to send this change of the application to my specific deployment definition, because I have a repository for this. So I have a couple of steps: the initialize Git, create a branch, update my definitions files, and send the commit as a pull request to the specific target branch that is main. And the result of this is this pull request via the pipeline. That is the modification of my image. And the source is the build pipeline that I create. That is this one. So the developer team don't need to modify the deployment definition file if they create a new version of the image of the application. It automatically is going to change as a pull request via the pipeline. So this is a cool stuff. So we can have the entire process from the continuous integration for the development environment, and also as an operator, as administrator, I can push my change directly using Git. So now is synchronizing again. Let's wait. Now I only have one pod. This means that I should have only one agent. If I refresh this, one agent. Yep. So, questions?
Well, more than question, I guess that's a really cool thing, because when you can see here that's not all integrated as one tool. You have to integrate it a couple of tools. Excuse me. And in this case, looks so simple. You looks that so simple. So
it looks
yeah. As a really interesting, that kind of things. But in this case, for your experience, what do you think that's any kind of process that maybe we have as a YAML pipeline, we can migrate it or include it as a GitOps operation?
All of
or
that
there
I
are
show
some
you
specific
is,
things?
No. All that I show you was created as a DevOps, Azure DevOps YAML pipeline. So the magic behind this is how you concatenate your different pipeline to basically accomplish the mission, right? Because as a developer, we have a build pipeline or CI pipeline for build validations, like restore my dependency, build my application, execute analysis code and security, and generate the deployment file, right? This is the first part. After that, we should take in consideration, this is a containerized application, which I should create a Docker file. So for that, I need another pipeline, another continuous integration pipeline for Docker image. So now from one, I go to the second one, that is generate my Docker image based on my previous build generator. So this is the second step, my Docker pipeline. So after I have my Docker image built, the next step is to use this image on my cluster. And normally we say, okay, I have my image available. I can tell to the administrator of Kubernetes to deploy it. And this guy create a manifesto and all of the configuration in a YAML and deploy it. At the end, it's the same step that we are doing on the pipeline. You can create it with scripts, with PowerShell, and with integration with Azure DevOps YAML pipeline. You can do it. Everything that I show you and the demo was based on YAML pipeline on Azure DevOps.
There are some limitations over, sorry, Ricardo. There are some limitations over the classic pipelines that we have on Azure. So we need to migrate that to YAML.
First of all, classic pipeline is going to end. Microsoft make the announcements is going to end in, I think, it's in 2 years, 2025. So, recommendation, move to YAML pipeline. Spoiler alert, you can do everything that you did in the release pipeline within the YAML pipeline and even more, because you can have a lot more options available. A lot of them. For example, dependencies, logic, for each. You can do like regular expression validation. You can do a lot of stuff that you cannot do it in the classic pipeline.
Yeah, and using templates also, and
you can
yeah,
you can use templates. You can basically apply logic between the environments. You can do a lot of stuff, like use your engineering skills in your pipeline. I don't use classic pipeline since I think 2 years.
Good. Yeah. Okay, Ricardo. Thanks, man.
You're welcome.
Okay. Well, I saw something very interesting, guys, that with these ARGOCD capabilities, we change the way that we deploy. We always deploy pushing changes. So right now we are basically changing to pull those changes. So I was wondering in one cool use for this capability, and if we offer something like software as a service we can use this, we can take advantage of this, because we can do something like our customers will be advised when a new version of the infrastructure or something is available, so they can decide if they want to update or not, right? Something like that.
Exactly. And also you have more control, because if something happened, you don't have to take care about like, oh shit, I break something. It's okay. It's just definition. Go back to the previous commit and that's it. That's the magic. Yeah.
Perfect, man. Yeah, what a cool use for that.
Yep. And let me stop. Also, this is not just theory. In matter of fact, all the biggest bank in West of Europe is using this. For example, I work as a consultant at Microsoft as a DevOps architect. I recently implemented this entire strategy for ABN AMRO. It's one of the biggest banks, and also for Rabobank. And now we are going to start in the next quarter with Banco Santander in Spain. Is almost all of the huge corporations that have cloud native application are adopting this practice. And this tool is kind of new. ARGOCD was released in the 2020. And now almost all the bigger enterprises is using it.
That's cool, man.
Ariel, I have a question regarding with that. This kind of process works as a pipeline, as a code. I mean, we can have versioning of this as a code, like a YAML things.
Yep. In matter of fact, that's the main. Let's call it like this way: the main capability. Your entire definition have a specific semantic version. So if you want to roll back to a specific semantic version of your configuration, you should do it.
Nice, good. Thank you. Got another question, guys? Because this is the side that we have to question to you guys. No?
Seems that no, man. No further questions. So
there is two options: or they understand, or they don't understand nothing. So let's say that they understand everything. So good.
I hope that.
I hope that too. So Ariel, thank you so much, man. Thank you so much for your knowledge, for your time for us.
Yeah.
No, you're welcome. I share one link on the chat. That is it's a web page with almost all the information that I share. Basically, my entire presentation was based on the information on this page. So feel free to take a look. It's a really well explaining article regarding GitOps, and the book they have right there is one of the best books that I read related of GitOps. There is a couple of them news, but this one was like the Santo Grial of the GitOps on the moment. It's like the Phoenix Project.
The Holy Grail.
Nice.
Exactly.
Thank you. Thanks, Ariel, and thanks everybody to join us to this session. That's really enjoyed to share knowledge. Like I will say, share to learn and learn to share. So the idea with this, guys, is you have a question or concern related with this kind of topics, feel free to ask here or write some question if you want to a personal message from Ariel. That's good to all. I think that's all for today, guys. Thanks everybody to join us. Thanks, Ariel. Was a real
thank you.
Thank you, my friends.
Gracias.
Thank you.
Okay,
Pásala
guys.
bien, Ariel.
See you around.
Hasta luego.
Bye.